Hello, good evening, everyone. Welcome back to Polkadot India Substrate Saturday Bootcamp. And today marks the last mentor session of the 3-month-long series. We're almost at the end of this bootcamp, and congratulations to all you guys for making it so far. It's definitely a commendable effort, and consistency surely needs to be recognized here. It will definitely take you places. It's great to see so much passion and enthusiasm to pick up something new and keep up the good work. And very good luck to you guys for what's ahead after this boot camp and for your Web3 journey. And yeah, post the boot camp is definitely exciting, as you guys will be placed in some amazing projects out there that are thriving in the Web3 space. So yes, not going to take more time. I'll quickly go ahead and pass the stage to Tejas and Lokesh. Meanwhile, we'll just keep sharing our community channel links on the chat box. So keep an eye and yeah, keep in touch with us. And yes, over to you, Tejas and Lokesh.
So as for today, we'll be covering like two things. We have divided this session into two sections. One is we'll be going through palette coupling, and the other would be we'll have a small quiz also, like we had last week. So we can start with coupling first, and then we'll also after that we'll progress to the quiz part.
Cool. Thanks, guys. So my dev environment is setting up, so probably there's a minute left. So guys, anything you guys want to share about how you've been feeling throughout the entire bootcamp? It's almost 2.5 months now. We'll probably have a Q&A at the end of the session, but I'm just buying some time until my code build.
These are like in general questions, not specific to Substrate. And like, what was your experience? Do you all want to share? Like, how hard was it, or how how challenging was it to take up a new domain altogether? Or anything that is relevant to your experience.
So yeah, getting back to the topic. So last week we had covered something called as tight coupling, where along by showcasing tight coupling, I had shown how we can build our own cryptocurrency, right? So this is going to be a continuation from what we had done last time. So the first step to learn was tight coupling. The second step is to learn how to loose couple your palettes. And what is tight coupling and what is loose coupling?
Before that, Lokesh, can we ask, like, or can you all tell us in chat, like, how many of you all know what coupling is? Just a yes or no would suffice.
So yeah, last time we had done this piece. So we can, by now, hopefully everybody have understood that when the way to tight couple, right? You mention your regular config, along with that you mention the palette config that you want to tight couple it with, and then once you've done your tight coupling, added it to runtime and all the other things, you can call the tight coupled palette using this kind of syntax. So far, like we are on the same page, hopefully, right? So yeah, you guys can just say yes or no, or maybe or no as well. Sorry. Today what I want to showcase is basically the loose coupling. So this is the document for anybody to learn about palette coupling, right? I mean, how do you couple palettes, and why do you need to couple palettes firstly, right? So like I said, one use case is when you want to use a palettes functionality, that is, say, to build your custom currency, and that is going to impact the storages of your parent palette, then that is a use case for you to tightly couple palettes. So that is what this says, and I encourage all of you to read through these things about tight coupling. So this piece we have already covered so far, right? So the next type is to loose couple palettes. So when do you use loose coupling? So loose coupling is basically a better alternative and a better way of writing code. A reason, because you don't want to write redundant code. So what redundancy is basically when you're just writing the same thing over and over again in multiple palettes. You're calling the same functions, you're writing the same storages. You don't want to do that because it's expensive and it's horrible, and you don't want to basically your runtime will go, your storages will go, everything will take a big hit, right? So that is where loose coupling comes into picture, to avoid redundancy, to make sure I can reuse. So to to bring in the concept of modularity and allow reuse of code, we have loose coupling as our option. So this is basically it. So yeah, we'll just get directly to the code, but I want all of you to go through this documentation, because this is like important, like why, what is loose coupling, what is tight coupling, and what you need to do it. So for today, right now, what I want to do is just showcase how you basically do a small bit of loose coupling. And yesterday in the Q&A, because some people had questions about how do you write your custom config and things. So loose coupling will kind of give you your answers to that as well. So yeah. And, so this piece of code is from last session, and abruptly I'm having a error which is not a code based error, but instead it is a new error that has popped up. Written on board.
It's not a code spaces error.
No, it's not a code spaces error. So this is the error. While building, you're getting something else, syncs.retain mute. And retain mute is not inside our package, it's inside something called as transaction pool, graph, validated, and all that. So this is directly from the Substance thing. And how do we fix this? Help add feature to create attributes to enable. Okay. But it should work even
Oh, it's an
without that.
unstable feature. I think if you like downgrade your version, it might work. I think in the new version they're using a lot of unstable features. Maybe that's the issue. Or a substrate.
Possibly something to do with that. So using it will allow to modify the elements of an array while filtering which elements we want to keep. Okay. What do I want to? Okay. There it doesn't go here, so I need to add it in the palette. Palette is used because I'm not using it here. But that is not inside our.
I think you'll have to place this macro over the sinks variable.
Over
The where the error is.
But the error is not in my code. It is inside
right. It's
Substrate
inside.
transaction pool. Yeah, it's inside the library dependency.
So you will have to place it there. I think it's better to use another template.
See, it's over here. We didn't find. No, this code was compiling last week. Like we did this. Probably there is something that. So there's a issue that has been indicating here for more information. I'll add the break to enable. See, hopefully,
It's building, huh?
I'm trying. Let's see. Okay, now it's back.
Yeah.
Oh, and but now it's back with something else. It's back with bool to option.
Again, unstable feature.
Parity DB.
Yeah. Are you downgrading the versions of specific packages? Sorry, I wasn't seeing the screen.
For today, we are not going to use this palette at all. I'll create a new one, but it's not letting me compile this. Okay, it says okay. If not, I have a base template. We can always check out from there.
Okay, Pratik. So we are going to cover a loose coupling, and we'll also have a small quiz after this, where we'll be asking some questions, and you know, it's more towards it's more like a theoretical quiz, and it's based off of Substrate document.
Well, let's not waste time here. I'll probably check out.
What was the error, Ramesh?
I'm not sure actually. It says there's some library issues, like probably it's the Cargo installation that is.
Which library is it? Where did it install?
Parity DB.
Okay. And it's 9.28, huh?
Yeah. This is a base template. Hopefully this will compile. Guys, meanwhile, this is comparing. You guys feel free to ask questions. Feel free to discuss whatever you want.
Sure.
Hey, Lokesh.
Hi, Krishan. Yeah.
So the first line of the code, can you just recap for us?
The
First line, like the first number one row.
okay, the same question. The feature STD and no STD. So
Yeah.
basically, what you're saying here is, so you're saying you're writing that if feature is, I mean, so the thing is, the default feature is no STD, and this is not for STD. So there's a documentation that I will pull that up. So yeah, so basically, if you see, it's basically piece of line in overall end of the thing is just saying that this piece of code is for no STD. And like I told you yesterday, Keshav, so the thing about STD and no STD. So how does a program compile on your system? So what is an STD library? Your standard library is one where you basically what do you do? You use all your standard components like literals, your strings, your data structures, your collections, your comparisons, your utils, and all that, right? And now, where does this STD library come from? It comes from the package that you download as a compilation target, like on the compilation layer for your language, right? Like say Java or Rust. When you download Rust or Java, you download all these things, even in C++, and you have a runtime that you'll define. If it's C++, you have GCC as your runtime. If you have Java, you have JVM virtual machine, which is your runtime. And like JRE is inside JVM, which is a runtime, which composes of all of these STD utilities. Now that is the runtime, right? Now similarly, Rust has the system as a runtime, right? You have your, so basically it's running on my native system where I have downloaded the STD file and kept. So far followed?
Yeah.
So now when I'm calling any function from STD, say I want STD string example. So then I'm able to call it. So, and if I run it, when I execute the program, because it's the runtime is on my system or native to my system, or inside a runtime which comprises of all of these STD libraries, it will be able to get that particular utility from the STD. But now, what is WASM? WASM is something that runs on the browser. By the name itself is something called as WebAssembly. Now, when I'm executing this code, it's not running on my system. Agreed? My runtime, the runtime for this code is not the system. The runtime for this code is your browser.
Mm-hmm.
Is your browser V8 engine. So on Chrome, it's you have an engine called V8. So on the V8 engine, are you installing Rust? Are you installing JVM like Java, or are you installing C++? No, right? Because your standard library comes from the installations, right? you're not installing all of this on your V8 engine or on the browser. You're just running the executable wasm file that is coming into your that is there in your code. So which is why not all functions that you write while coding on a wasm compilation target will work if you're using standard. That is why they have another way. They have this feature saying that now I'm writing this code with feature for no STD, and if it is no STD, I will make sure to use utilities that I want. I can still use a vector or a string for what my code, but then it won't come from your regular standard package. It'll come from something else. For example, even in here, if you see, you do not import your regular things from your STD. If you instead you import everything from SPSTD. Now, why you use SPSTD? Because SPSTD exposes a feature called no STD. So all your things inside SPSTD will be able to, you will still be able to use, which is written like specifically for a no STD compilation target. You understand? Like this is the main difference.
Yeah,
This is the main thing. But how to put it in much, I mean, this is the overall picture of what it is. But if you want to read very in detail about all this, you can always like, I mean, not this. This is not actually answering it, but you can read about this. So, sorry, I'll just leave it.
Paste this link. Yeah, and then what I understood, now I'm pretty clear, but just let me tell so that if I am wrong and you can correct me.
Yeah.
Like we are just writing this to say the compiler that hey, while you are making the binary, you have to export the library functions or tools or not, right? So suppose I am going to run this somewhere, Rust is already installed. So my binary will be
you can use
lighter
STD
version.
from there. Yes.
Yeah, so my binary will be lighter version, but now I'm telling my code where I'm going to run it somewhere Rust is not there. So export all the standard library and features in the binary so that it can run there also where Rust is not there.
No, so your regular STD, even if you export, won't run in WebAssembly because it's not written for such a runtime.
Okay.
That is why you need SPSTD. If you, I had shown you, right? You have something called SPSTD, and again you have SP core. So all these, so you have the regular functions. Your SPSTD basically gives you all the basic things that your regular things give. Cannot edit in. Oh, sorry. Yeah. So say SPSTD. So if you see, it will give you all the normal things. It has a comparator. So comparator gives you what? Equal, not equal to, partial equation, max, min. All these are things that come from your regular SPSTD file, like regular STD library, right? For Rust or for any language. But since that is not I mean, like it's not compatible. Compatible is the right keyword. The regular standard library is not compatible for a wasm runtime. Okay, so which is why they write it specifically in SPSTD, which releases a feature called no STD, where you can use all these functions again, min, max, and all that.
Got it.
So it is basically compatibility.
Yeah, got it. Thank you so much.
Yeah, sure. And so yeah, we have the same error. This is quite weird. In any of my code, it's coming up, and this is not an error for the code base. It is something to do with the library. You can see it is inside my cargo. It's inside Substrate. Okay. I'll give this try one more last try, but I will start explaining loose coupling. This is just a normal thing. I don't want to waste too much time. So yeah, about loose coupling. So like I shared the documentation. It's also here. So last time, again, I'll just review what we did. So last time when we wanted to tight couple, we wanted to create our own currency. Tight coupling was done in a format where along with the config, you will do a plus symbol and then you will write the palette that you want to tightly couple with, right? This is the first and foremost step. Then you will implement all the methods for that palette and all those things, and then you can start using it with the syntax that was shown, right? You can call the palette, like say we use palette assets, so it was palette assets palette, and you were able to get the piece of code, right? You were able to talk to, I mean, get all the functions that are there in palette assets. While so camp assets is our palette, and since I have tightly coupled camp assets with palette assets, I was able to call all the functions of the palette assets inside this inside my palette. So this is the way of tight coupling. So what is loose coupling? Loose coupling is just a so in OOPS concepts, like to explain, you guys must have known about interfaces. Interfaces is an abstraction basically for your class, right? Similarly, loose coupling is kind of an abstraction for your palettes that you want to use. So in loose coupling, I don't want to directly talk to that palette, like as in I need to tightly couple it and all that. I'm not going to make library like calls or changes to the storage where it is impacting even my palette. No, I'm not going to do that. Instead, I just want certain functions from the from any palette, be it, to be called for my use case. So that is what we are. That is what loose coupling will achieve. So if you see here, the first step is you import something else. Like so, they want to show you how they're implementing loose coupling. So here we have something called as currency trait. Currency trait comes from your frame support traits currency. Now let's go have a look at how currency trait is. So what is a trait? Like I said, in OOPS, it's an interface. Interface is an abstraction. In traits, trait itself is an abstraction, right? Frame support traits. So yeah, so we have the frame support traits here. Frame support traits currency. So what is a currency trait? So whenever you want to loose couple, you're basically worried about the trait that you want to use, because the trait will define the functions that this trait will have, and we only want to use those functions. So if you see here, we are trying to use the currency trait, and the currency trait has these total functions. You have something called as a type, where you have balance, then you have positive imbalance, then you have negative imbalance. These are all the types required for this trait to be implemented. And then these are the functions that I can call if I implement for this currency. So if you see here, trait is similar to an interface in OOPS programming, where you are not writing the business logic for your function. You're only defining what your inputs for the function is and what are the output for the function is. So if you see here, a total balance will take who, which is an of type account ID, and just return the balance. The implementation of how you're returning the balance will be on inside the palette. So far, are you guys following? Can you just like respond with yes? No.
Yeah.
Yeah. So in normal trades as well, what we do is we always implement the trade, right? So currency trait has 3 types, and there are so many functions that allows you to basically implement for your palette that you need to that you can use to call. So out of this, say like in palette assets also, there'll be a trait that will be implemented, right? Or in any palette, like you want to implement your own trait, we will write our own custom traits in regularly. So to compare this with OOPS concept, what you do is when you say you want to build, you want to create multiple instances of animal, a dog, a cat, a lion, or whatever it is, then the way you would do it in programming is you first create a class of animal, right? You create a class of animal, and all animals will have a name. All animals will have a sound that it makes, right? So the class animal will consist of two attributes. One is the name and one is the sound, right? Similarly, in Rust, what we do is we write a trait. Instead of class animal, we'll write a trait animal. The trait animal will have types of sound and name, and it'll have some functions like you can make sound or say name or whatever, right? So that is the same thing that we're trying to do here. And in loose coupling, we will just attach the trait name to the type that we want to say. Now, so for example, here I want to use this. I'm creating a custom type. Yesterday, I think one of the person in the Q&A had asked. So this is how we do it. So we create your own type that you want to use. You just give a name and you just say it's of type. But now here is where you define what does this type need to implement. So it needs to implement the currency trait. So this, how do I know it's a currency trait? Because you see here, the first thing is you're importing the currency trait from your frame support traits currency, right? You're importing this, and then this takes a thing called account ID, right? That you can see here. The definition of currency trait itself says that there is pub trait currency, which takes account ID, and you need to implement that. So that is what we're doing. So we are creating a custom type as currency. And similarly,
Okay.
now how do you, yeah.
So in type local currency, instead of currency, can I mention U64 or U32 also?
Type local currency, where? Yes, yeah.
I can do that, right? So it's not like fixed that I have to add currency only.
No, it's not fixed. So it's currency trait is just an example. So like I said, if I want to build my own trait, like say I have a trait called animal that I have built, which has functions to make sound, and it has attributes of name and sound that the animal makes, then what I would do is I will pass the animal trait here, right? So I want my type local, like my variable or my trait to implement the animal trait. That is how I will write the code. So I will show some examples so that we can get past this. So the main thing is you come here, you implement your config, and now you just want the currency trait, because I want to get the balance of my function. See, total issuance is basically, it'll return the total balance that is there in an account in the currency trait. So now what is the difference between total issuance and just normal balance or total balance? So the difference is that, see, an account can have money, but there is also something called as residual deposit or existential deposit, right? So when you go to a bank, you have something like, they have clauses where you say like, you want to have an account in our bank, you need to maintain a minimum balance of 2,000 for you to maintain an account in our bank. If it is not a salaried account, right? So similarly, you have that is where the concept of total balance comes. So now if you have 5,000 in your account, your total balance is 5,000, but out of that total balance, how much is the balance that you can actually spend? Now say if that 2,000 is the minimum deposit, and say there's a lockable, say for you have bought an NFT or something, and another 2,000 got blocked in your account. Now the amount you can actually spend is just 3,000, but you still have 5,000 in your account. So that is the difference. So total issuance will give you the balance that you can spend. Got it? And total balance will give you the total balance in your account. So I hope that is clear. So to get the total balance for an account, so to get the total balance of an account, so I don't need to, so on Substrate, how do I find a balance of an account ID? So I have I have this as my account. How do I know how much of balance this account ID has, right? I need to figure that out. So you call something called as the balance function, the total balance of the function. Where does that come from? It comes from palette balances, and this was covered, I think, by Tejas in the initial days. I hope all of you guys remember that. If you guys remember palette balances, just say high five or whatever. But yeah. So yeah, so you use palette balances, right? So now let me just show you the palette balances, the code, the actual code that they've written. So palette balances.
Okay. So Jim has a question. So he wants you to repeat the example for total issuance. So he says total balance is 5K and minimum balance is 3K. What is total issuance?
Okay, that. So what I was telling Jim is this. So now say you have an account ID. Now forget about the minimum thing. You have created a new account in your on the blockchain. You have 5K as the total balance. Now you have bought an NFT. Now say you have not bought, you have bidded for an NFT on one of the NFT providers, and that NFT costs you 2K. Got it? And now when you're bidded for that NFT, that they would have locked that amount on in your account. So you have 5K as your total balance, and the 2K is something that is locked since you have done some bidding for an NFT, right? So this amount you have bidded. So right now, how much money can you actually spend from this? You can only spend 3K, right? So the difference between total issuance will return 3K as the answer, because this is the amount you can spend as total issuance, but the total balance in your account, you have 5K, right? So that is what it is, basically. I hope
free
that
balance,
answer.
correct?
Yes, free balance is also same. Yeah, I think you got the answer. So yeah, so that is what it is. And now coming back to palette balances. So why I want to show you the code is I can write the code and show you, but then it's more important for us to look at the code and understand. And this is a simple concept. So yeah.
So Lokesh, there's one more question. Will the total issuance change automatically to 5K when the bidding time expires?
Yeah, once the amount is locked, yeah, you will be able to. So basically, like people like to put in much simpler terms, say you have an account ID, you have 10,000 in your account, and you have opened a fixed deposit. So you have put 5,000 as under fixed deposit, right? So now that is fixed for a term of one year. Now, but your total balance in your account is still going to be 10,000. But out of that 10,000, how much of the balance can you actually spend? It's only 5,000, right? Because the remaining 5,000 you put as FD for 1 year. Correct. So now the total issuance will be 5K while your total balance is 10K. Is that clear? Yes, no?
Yep.
Cool. Yeah. So I just want to show you guys how the currency rate is implemented.
So mostly this currency trade from balances is used to make transactions, right?
Yes. So if you see now, I'm in palette balances, right? We all came to palette balances lib.rs. We are in lib.rs file. Now I do just to find an account balance for my palette, I don't need to import palette balances in my cargo in my palette, like the way we did it for palette assets, right? So let me just switch the branch. Camp assets, right? So if you see here, the first step to tight coupling was we had to import the palette assets in our cargo terminal. So in tight coupling, I can avoid this. I don't have to add palette balances as my dependency just to find an account, the balance of an account, right? So what I do is I know that palette balances implements the currency trade. How do I know that? I'm showing you the line of code where they've implemented it. So this is what they're doing. So they're doing implement currency trade for palette. So which palette are we in? And we are in palette balances. So they've implemented the thing. So if you see, they've defined type balance, the positive imbalance and the negative imbalance. These are the three types that were defined as the trade was defined here. And now they've implemented all the functions. So remember I said the trait, when you write a trait, it's similar by just similar to an interface. You're not writing the logic for your function. But here, when you start implementing it for your specific palette, you're implementing the logic as well. So So to get the total issuance, they have a data structure called total issuance, and they're calling the get function for the respective account, right? And similarly, they have implemented all the functions that the currency trade implements. Now as a palette writer, I just want to call my palette. I want to find the balance of an account ID. So first I've defined that I need a variable. Or I need a type that implements the currency trade, because I just want to find a balance of an account. I don't want to deal with palette balances as a whole. What all the functions that palette balances gives, I don't want that. I just want certain functionalities. Out of that, currency trades is something that gets you the balance. So I implement that currency trade. Similarly, you want to add on to the functionalities, you can just add the plus symbol and write the other functionalities or other traits as well that you want to implement. And then you come here, and this is the syntax of calling the function. So you just call t local currency. T, when you say T, like I mentioned, it goes to your config. From your config, I call my type local currency. Now local currency is a type that implements my currency trade. So I can access all the methods of my currency trade. So not just total issuance, anything from it. So by doing that, now I can get the total balance of an account. So this is basically loose coupling. Now, what are the main advantages? And loose coupling is always the first solution that you should go to while you want to implement palettes. Tight coupling should be a last solution, and tight coupling, there are certain use cases when you want to tight couple palettes. It's mainly when your storage is going to affect, like a change in your storage will affect the storage of your parent. That is one use case. Second, you have a direct relationship with these two palettes. Like, I mean, the one is the parent, which will, anything impact on the child is going to affect your parent as well. But if you see loose coupling, these are like two different entities. So these can exist without each other. But when it comes to tight coupling, the child can't live without the parent. Is that better way of putting things? Hopefully, but hope that made sense. Yes, no?
Yes.
Cool. So that is mostly about tight coupling. And the moment I say currency trade, so when you implement at runtime, I say my total currency, and I need to pass a variable that implements the currency trade. And like I showed you, the balance palette balances implements the currency trade. Right? I'll just share this line of code for all of you to just read through it. And this is how you implement the trait normally for any palette. And now that I can, I know which palette implements that thing. I will implement that particular palette. Palette balance is anyways implemented here, so I don't need to implement it again. And then I just pass the variable name that is for palette balances. And this anyway, it will understand. So when I pass balances here, one thing to notice, in tight coupling, I will be able to access everything that palette provides, right? Because we are importing it as a dependency. But when in loose coupling, you are only worried about a certain part of it, which is currency trade. There are many other things that palette balances implement. Like, how do I know that? How can I figure that out? You can look at this. So above palette, they have also implemented the imbalance trade. You can see, right? So this line, they've implemented something called as the imbalance trade. But I don't want to use this imbalance trade. I don't want all these functionalities. So I just want certain small things. So this is where I'm reusing the code. I'm not putting palette balances as my dependency, increasing the whole computation size and all that. I just want a certain specific function. And the second thing to note is my palette can exist even if palette balances is not there. I don't need palette balances only like specifically to implement the currency trade. There are palette assets also implement currency trade. So I here, instead of passing balances, I can even implement assets and pass assets here, right? I can pass any palette that implements the currency trade. But you just need to know which palette defines your use case. And that's what it is. So you see, this is the third advantage. You don't necessarily need to depend on one parent that has the type. It can have, there are multiple palettes. You can have custom palettes that implement the trade. It can be anything. It doesn't necessarily have to be balances. So this is mostly about loose coupling. Let me just show some code examples. So I was going to write the same code, but since this is a normal error, let's not worry about this. And also, since this was the last session, I wanted to cover how important it is for us to read code. So now let's go to marketplace. So I'm going to showcase both how to go through codes. So let's go to projects. And yeah, yesterday I think someone in the Q&A session, I don't know, but had asked how you learn, how do you write implementation for trades and custom things. So I hope this at least answers a little bit of things that you have. Like basically you need to look for the trades that are implemented. You need to go find it. Is that clear? I think it was Keshav or I guess, yeah. So yeah, that's how you do it. And now once I come into projects, there's a lot of code bases, right? Now let's look at an NFT project, like, and how they have done their things, right? So say there's Unique Networks. Unique Network is an NFT project that we just had a session for the Unique Network last week, right? Or the week before that, I believe. But yeah, so let's come to the repo. So this is the most important thing for anybody to grow. Like once you're done with all your tutorials, you need to come to go through code spaces, understand the code. So if you come here, they have their palette section. Let's look at their what palette? The unique palette, right? Unique is their name. So let's look at the unique palette. So just looking at the code, I want you guys to tell me what are the concepts that they've implemented, right? What are the different things that they're doing? So I have come to the part of my config. So can anybody come up on mic and tell me what are the mechanisms that they're using in terms of coupling? I only want you guys to look at code from here to here. Nothing else.
The configuration part.
Yeah. It's fine even if you're this one, just come up and tell us like.
It is tight coupling with palette common.
Yeah.
And also it is implementing triad sized and type info.
Yes. So these are tight coupling. This is correct. One is correct. There is also loose coupling where they have common weight info, refungible extension weight info. This is also loose coupling.
Yeah.
Okay, so yeah, so this is how you just go open code bases, go look at their libraries, see what it is, how they've implemented. Are you able to grasp what they've implemented? So now let's look at how they've implemented this particular palette for the runtime. Now they have used both tight coupling for palette common, and they're using loose coupling for extensible weight info and common weight info, right? So let's just go back to their
And this
runtime.
is Substrate V1. Okay, so the syntax is a bit different here.
Yeah. But the config was the same, so I think it was fine.
Right. I mean, you don't call the macros, right? Like you do in V3.
Yeah. Let's open lib.rs. Let's look at. So yeah, if you see they're implementing palette unique for runtime. So the refungible thing comes from something called as common weights. So where does common weights come from? Now I need to figure out common weights because common weights implements the refungible parts. So where does common weights come from? I don't know. There are only 3 instances. 2 of which are here. It is coming from your unique runtime common weights. So it is basically inside your runtime common weights and common weights. They've implemented common weights over there. So let us go to that place. Unique runtime common. Runtime common is here. So path is under common. So let's go to that. Let's go to palettes. Let's go to common. And now let's see if the refungible trait is implemented here. So yeah, have we reached the point of code? They've implemented the trait refungible extension weight info in palette common. So you see, they're using another palette called palette common, and they've implemented refungible extension weight info, which in turn they're using in their unique palette. Like, understood? This is how they loosely coupled these two palettes. Guys, is that clear?
Yes.
Okay, hope everybody understood that. And yeah, so this is the first step to start looking at other people's code. Try to understand what the code that they've written, look at how they've written the code, the functions that they've implemented. And so yeah, down the lane, like once you start writing a lot of code, and maybe 3 months down the lane when you're like into Substrate and all that, these concepts should be like fairly easier. I understand right now it must have been like a very confusing thing to put into your head, right? But then it's fine. It is meant to be confusing, but as you keep practicing, like as you keep writing, it becomes very clear. But the flow is very simple. Like I showed you, the flow and the concept of it is simple. It's just that it becomes a bit confusing overall. But yeah, that's mostly of what I wanted to cover today, because I just want to make sure that all of you are done understanding the concepts of writing a palette. How do you design a palette? So these are all concepts of how one writes a palette, right? These are different approaches. And yeah, I just want everybody to make sure that if you're really focused about getting into Substrate or Polkadot development, make sure you come into this build and you have done everything that is there here under build and also under references. So, but at least you need to implement everything as code, like write it, practice it, code it, read from other code, open source code that you can find. And yeah, that is mainly an advice probably. If you are confident with these topics, you are confident to write your own palettes like on production level. So far, by what we have done in the code bootcamp, all of you must be able to easily write normal palettes, right? Just if without tight coupling, without loose coupling, just writing palette functions and events, it must be clear now. And now we've covered this, and yeah, these are mostly the basics that you guys should know. And I guess that's it from my end, and all the best, guys. I will give it over to Tejas for
Super.
his part.
So about writing palettes also, like how I think of writing palette is like writing independent palettes, those have independent functionalities. So my advice for you all would be, if you're creating a project, try writing independent palettes and try to integrate those independent palettes into your own project. So that will give you a good grip on writing all the palettes. Like Lokesh said, that the flow is simple and the same, so it doesn't change. The only change that is that is there inside this code base is that you can add more functionalities on top of the base palettes or the base flow or the basic flow. So that's how the palettes are made. So cool. I think we can move on to the quiz section. So basically this quiz is for not like a quiz. It's like it's more like empowering you with additional knowledge, right? So this is based off of Substrate docs, as I mentioned earlier. So I'll be like asking you some questions. You can answer to the best of your knowledge, and if no, I'll be reading a nice theoretical answer for that. So all right. Okay, so I think we can start with the quiz.
Yeah.
So the first question would be, what do the libraries with SC prefixes do? So there are many libraries that you must have seen start with a specific prefix, right? Like the frame palettes, like the SP palettes, right?
Yeah.
So
they're SP.
Right. So it means something. So nothing is without meaning inside this TOML or inside these palettes. Right?
Mm.
And all of these palettes are directed towards some functionality. So can you all tell me, like, what do the libraries with the SC prefixes do? Has anybody read about that? No.
Yeah, like I said, it's not meant for everybody to answer. It's more like if you guys want to interact rather than just chat, you just talk normally. It's not necessary for you guys to come on video, but you can just talk.
All right.
So
it's more of a discussion.
Substrate primitives which are meant to be all the time and in every blockchain node. So it has to be there, kind of.
No. Okay, so I'll read about the SC prefix part. So the libraries that enable Substrate node to handle its network responsibilities, including consensus and block execution, are Rust crates that use the SC prefix in the crate name. For example, the SC service library is responsible for building the networking layer for Substrate blockchains, managing the communication between network participants and the transaction pool. So it's basically to handle network responsibilities. So that's what the SC prefixes libraries do. Is that clear?
Yeah.
Yes.
Thanks.
Tejas, do you want to share screen for the definitions? And that would, like, people who are
Basically,
not
saying
following.
the SC prefix handles networking and consensus. Is that what you're trying to say?
Yes.
Okay.
Like consensus and block executions.
Execution.
Yes.
Okay.
Similarly, can you all tell me what the SP prefixes do? The libraries that use the SP prefixes.
So we need to name the libraries.
No, you just need to tell us what does it. What do you
so
use?
what does it stand for? So there are many, like SP STD, SP runtime. So there are these different libraries that start with a specific prefix, right? Which is SP for now. So can you tell me, like, what do these SP prefixes specify?
SP means substrate primitives. SPIO IO stands for input output. Likewise, we have core, SP core.
Right.
There are many RPC, something like that.
Right. All right. So I'll read about this also. The libraries that provide the communication layer between the outer node and the runtime are Rust crates that use the SP prefix in the crate name. For example, like you said, the STD library is used for using primitives from the Rust standard library. So going back to the conversation between the standard library and the no standard library, right? So standard library is not used, correct, in Substrate's runtime. So you come up with different functionalities apart from the STD crate, and you created a different library altogether, which does not consist of the standard library. So that's what SPSTT stands for. So it's not your standard library. It's a library which is specially designed for Substrate.
Correct.
From which you use primitives.
Basically, it's by the name itself. You guys can identify it. It holds all the primitives that is required for your Substrate development. What are primitives? Primitives are all your data types, the structures, your comparators, all those kind of stuff. Cool. This is. Do you want to share screen?
Okay. I'm actually.
I mean, it's fine. It's just a discussion, right? So
it's just a discussion, actually. Let's just say. Actually, I'm reading off of an Excel sheet, so I think I'll ask first, and then we can, then I can share the screen. What about that?
Yeah.
Will that be fine?
Yeah, I guess so. Yeah.
Hey, I just want to put my request in advance. Like after the quiz, if it is possible for you guys to show like how to change the consensus model from the default, which comes in the node template. So what we all did is like download it and build it and run it. but how to change the any default thing there, like from grandpa to something else or babe to aura or like that.
So you just write a palette. So the answer to that is direct. So you just write your own consensus as a palette and put that in place of grandpa.
Oh,
In place of grandpa and babe, you will replace that with your palette, your custom consensus palette that you write.
so switching between the existing ones would be easier. Like proof of work, how can we change it from proof
Yeah,
of?
anybody can develop their own consensus, right?
Consensus.
You can do it as your palette, as a palette method. You can, so, and then all you need to do is just change the variables that are requiring to give you the consensus in the substrate template. Wherever grandpa is being called used, you just change that to the consensus that you have built. So in substrate, the consensus mechanisms are handled by grandpa, babe, and aura, right? Aura and babe handle the initialization, where grandpa is the finality factor. So in your palette, you just need to make sure you're writing your consensus based on whatever it is, and at runtime specify that your consensus will be used as your, I mean, the custom palette that you have built.
Oh, got it.
Yeah.
Thanks.
Sure.
All right. Now, like the SP prefixes, can you all tell me what do the frame prefixes like? What are the frame prefixes libraries used for, or what do they signify?
I think frame prefixes is for palettes that are like required for, like, would I say, like the minimum required palettes for the blockchain to function.
Right.
I think that's all I can say.
Right. Yeah, we can consider that. Jibril. So I'll read out to you the libraries that enable you to build the runtime logic and to encode and decode the information passed into and out of the runtime are Rust scripts that use the frame prefix. So basically, like you said, the frame libraries provide the infrastructure for the runtime or your substrate node, right? For example, the frame system library provides a basic set of functions for interacting with other substrate components, right? And the frame support enables you to declare runtimes like storage items, errors, events, and stuff like that, right? So to sum it up, your frame prefixes build the infrastructure of your, or provide the infrastructure for your substrate node. So is that clear?
Yeah.
Yes, that's clear.
Awesome. Now, all right. This is a tricky one. Can you all tell me what is a scale codec? What does the acronym stand for, and what is its importance?
Yeah, scale codecs acronym, I don't remember full form, but the functionality is like serializing and deserializing.
Right.
From one palette to other palette, or when two stuff are communicating, then that needs to be serialized before transmission, and that needs to be deserialized when received. So that scale encoding and coding is used there. There are other.
Yeah. The prefix, I think the acronym is, actually Googled it. Simple, concatenated, aggregate, little endian.
No issues. You're all learning. Cool. So I'll read out to you guys. So Substrate uses a lightweight and efficient encoding and decoding program to optimize how data is sent and received over the network. Right. The program used to serialize and deserialize data, like you said, is called the scale codec, with scale being an acronym for simple concatenated aggregated little endian. Aggregate little endian. That's too much. But the scale codec is a critical component for communication between the runtime and the outer node. Okay, so it's basically the thing that holds or helps you communicate between the runtime and the outer node. Like you said, to sum it up, it's for serializing and deserializing data over the chain. Is that clear?
Yeah, thank you.
Awesome. Okay, so now you all have used storage values and storage maps, right? So can you tell me what is the storage double map and the storage n map?
Storage double map allows you to store in a key value manner.
Storage
Like
map does the same thing.
Same thing.
Storage double map, there the value will be another map, okay, where key value can be there.
I think it's it maps two keys to a value, or I think something like that.
Yep.
Yeah, Jibril is correct. So it's two keys. One
Yeah,
Sorry, yeah.
while the storage map is like it maps n keys to different values, I guess, or one value.
Yeah, correct. So key, instead of being one item, it is the map. And in case of storage double map, in case of n map, it can be like x, y, z coordinate has value something 10. So x, y, z being the key is will be considered a storage 3 map.
That will come in storage n map. So when you have more than two keys, so that comes under storage n map. And when you have two keys for the same key value pairs, that is called a storage double map.
Yeah. Keshav, I just want to clear one thing. It doesn't have a map inside a map. No, it's not. It doesn't have anything like that. It's just that two keys. It's a tuple of two keys which has one value. That is storage map. Storage n map is a tuple of multiple keys for one single value.
Yeah, thanks.
I'll read out the documentation. So storage double map used as an implementation of a storage map with two keys to provide the ability to efficiently remove all entries that have a common first key. Storage n map used to store a mapping with an arbitrary number of keys. It can be used as a basis to build a triple storage map, a quadruple storage map, and so on. Is that clear?
We used this in the assignment there, where we had the task was to store the number of downloads user wise. So there has to be a storage double map where user and the hash key, how many times it is downloaded.
Okay.
Yeah.
Cool. Yeah, that's one use case. Yeah.
Cool. All right. So this one is actually important. So how is the can you tell me like how is the final fee calculated?
What in that? Pardon?
The final fee for a transaction, how is it calculated? Have you all read about this in the docs?
Yeah,
I've not read
In terms of all the
I think I'll assume based on maybe probably the weights or through benchmarking, one of them, I'm not sure. The weights of benchmarking.
That is one part, yes.
Okay.
But it
How much
just
the
doesn't.
the size of the bytes we are uploading, and then how much transaction storage values are changing. This is the second part, and there is a third part also that I don't know.
Right. So it consists of different components actually. Okay, it's not just the weight that that we are so accustomed to. Like we apply weights for our pallets, sorry, for our extrinsics, right? So that's not the only thing. So I'll read out the documentation to you. Don't worry, I'll be sharing the screen also. No issues. I'm just reading out the questions. That's why I'm not sharing at the moment. So okay, so there are like 4 parts for the final fee. The final fee for a transaction is calculated using the following parameters. Right? One is called the base fee. This is the minimum amount a user pays for a transaction. It is declared as a base weight in the runtime and converted to a fee using weight to fee. So basically, this base fee is converted. This is the weight which is converted to a fee, and this is the minimum amount a user has to pay for a transaction. The second is the weight fee, a fee proportional to the execution time of your that a transaction consumes. So, for example, if you make a transaction, that also requires a fee, right? That is called your weight fee. Third is the length fee, a fee proportional to the encoded length of the transaction. All right. So it's like how long is your transaction going to take, right? So fourth one, which is an optional one, it's called a tip. So why? What does this signify? This is an optional tip to increase the priority of your transaction. Okay, giving it a higher chance to be included by the transaction queue. All right. So the base fee and the proportional and proportional weight and length fees constitute the inclusion fee. So the first three, the base fee, the weight fee, and the length fee, are your inclusion fee, and that is mandatory for making a transaction. A tip is optional, right? You can give a tip so that your transaction takes precedence, but these three things, the base fee, the weight fee, and the length fee, have to be are to be paid for making a transaction successful, right? And one more thing, the inclusion fee, like I said, the inclusion fee is the minimum fee that must be available for transaction to be included in a block. All right. One more thing, the transaction payment palette provides the basic logic for calculating the inclusion fee. All right. So there are 4 things that you need to look into here. The 4 things constitute your calculation of fees. One is the base fee, the weight fee, the length fee, and the tip. All right, you can I think you can just go with the acronyms like BWLT, something like that, just to remember. All right.
Yeah, so all of them are customizable in Substrate?
Yes, all of them are customized. So you have a transaction payment palette, right, which provides the basic logic for calculating the inclusion fee. So you can customize that palette also, or you can create your own payment palette logic for making the payments.
Okay, so if I say I want to make a blockchain where no gas fee is there, is that possible?
That is possible. I mean,
Yeah, you can.
but you know
But
why you shouldn't do
yes, right?
that? Sorry, Jibril?
Yes, I was like, yeah, it's possible, but then you probably be spammed with like different transactions since there's no limit to, like, there's nothing stopping anyone from just
Exactly.
making any transaction here and just probably overload the chain, which is nonsense.
And in Substrate, while you're writing your extensive, there's something called as pays fee, and you can say pays fee as no. So if you say pays fee as no, it's basically no gas fee.
Okay, cool.
So,
And also even like for like what I see in economic like sustainability terms, for let's say okay, you're building a blockchain, definitely you want it to be kind of
Yeah,
sustainable.
then has to be an economic model around it.
Yeah, economic
No,
model,
I
yeah,
just
thank
asked
you.
to be sure, sure. Just I was asking in other terms how much customizable it is.
Okay,
Yeah.
yeah, definitely can be free. I guess.
Yeah, there is a option itself. So there's a pays fee option. By default, it is true. If you just change that to false, all your extensives will be not charged basically.
so is there any predefined functions or library we use for these transaction? Just like in Solidity, we use say mass function, right, to calculate it as well as to restrict the for the security, to restrict the re-withdrawal and all that, right? So if that is not here, that may be possible that it can be hackable, okay, as well as there are some hack, you can say, scenarios I came across where they can hack with duplicate functions, okay, and by the first withdrawal, okay. By this way, a hacker can easily hack the contract as well as they can manipulate it. So is there any specific library which can restrict these malfunctioning as well as in proper way we can transact it? Yeah.
Yes. So to answer your question, it is yes. There are libraries. So when you clone your Substrate node template, right? By default, when you're cloning it from your GitHub, what happens is you are taking all the security features that Polkadot natively implements. So when you're cloning Substrate node template, what happens is you take all these libraries that are already implemented by Polkadot as your main thing. And Polkadot has a set of security measures. So yeah. So here, this is the main repo where you will be able to find everything that you want. So they have a set of functions and a set of libraries written to limit to basically allow security that is watching your chain at all times. One at code level, one at execution time level, one at runtime, like monitoring your node. So there are separate softwares that it's called the Polkadot telemetry, where you can go and find what is there. So there are, I can share all the links. There are all these things are available. And if you, as a developer, you are building your custom chain on Substrate and you want to change the way your security protocols, like the way, like for example, like you said, one such thing like a re-entrancy attack and all that, there are libraries that you can call to say, to kind of at a code level, you can restrict certain functions. For example, for a re-entrancy attack, you define a variable that this extrinsic is being called at the moment of execution, and the flag will change to false, or a count that maintains that this was called this time. So unless the count is increased, that function will not. So you know that if the count is not increased, that function is still running. So this is one such example. So basically this is the thing. So this is called a Polkadot telemetry. So what the telemetry basically shows you, these are the nodes. These are the nodes connected to your Polkadot. Now all of these nodes will not have a security measure, right? Rajesh, like you can't implement security measure like the custom things. But so what happens is, whenever you're running, these nodes are running the Polkadot code. This basically code base, and similar to your node template. So whenever you're running these, all these default security measures that Polkadot implements will be implemented for your the parachain that you're running or as a node. Basically that is what it is. I hope that answered part of your question.
Yeah, got it. So is there any testing scenarios, or we can create the test test classes to check out the exact functionality over here?
Yeah, there are a lot of things that you can do. It's all in the code base, like you need to this one, but probably the right way to start is coming to your polkadot.network location, and from here, once you come, you can read about all of these things. So once you come to documentation, so I'll just share this link in chat.
Yeah. Thank you.
So yeah. So once you come here, you will start looking at all the different things that Polkadot normally this one. See how to protect yourself from scams, right? So they have written a concept for them to like basically avoid all these things, and they also have like custom things where launches, video tutorials, parachain, comprises. So this is for those guys who are asking about custom consensus that you want to ask. So I think Keshav, you can also go through these things. You can see they have an endpause election algorithm, and this is all. This is mainly what Polkadot does, and you can understand the entire thing that they are using. So by default, when you're using, all of this is open for you when you're using the Substrate node template. And so yeah, see what is WebAssembly. Again, you have all these things. Exactly to show you the. So yeah, so once you come to this open source Polkadot stack, you find all the tools that you would mainly use. So Rajesh, this is the place where you will need to come looking to for maintenance tools, signatures. Signatures will handle your multi-signature account, people who are talking to it, networking, and all these things. And you can see how the communication is basically happening. They are showing you that as well. And in terms of exact security, so one is cryptography. So one main thing about Polkadot security is the cryptography they use. Like I said, ED25519 is used for your private keys, while SR25599 is a concept used for your public keys. So similarly, there are other things. So you can see your grandpa as a consensus requires you to enter your private address, which is of type ED25519. Any other encryption will not be allowed. So this is one layer of security. So this, because grandpa is the one who has the final say for the block finalization. So block gets created only after grandpa says okay. And similarly now babe is the block initializer, so it takes the public address, basically SR25519. And yeah, so similarly for a node, like I said in the telemetry, these are all nodes. For this node to run, it will have its own account ID, who is the validator, or you're a nominator in an NPOS. So NPOS is the consensus that Polkadot uses. So in NPOS you have the concept of nominators and validators. So when you run a node, you will either be a nominator or you'll either be a validator, right? So by default, if you run it, you will be a nominator. So when you run such a parachain, as a nominator, you will be given a public address. That public address is what you need to pass to your main consensus when you're connecting to it, right? So again, so these are all basically your security measures that the chain has to ensure security. And this is where you can also come and start implementing the stuff that you want to. Rajesh, is that clear?
Yeah, fine. But first of all, I have to go through all this document to understand
Exactly.
properly.
So yeah, to begin with, there are a lot of protocols. So you have ECDSA, you have a DSA, you have a lot of protocols that are working on. So when you are talking about security, which is an advanced concept, it all is based on certain protocol layers that the chain implements. So if you want to write your own thing, you need to first define your protocol, then implement it. And how do you test it on your code? So you take the code and just replace the security module that you find out the security module first in the code and replace that with the one that is already being used. That's how you would test it out.
Okay, got it.
Cool. Yeah. I think Jibril has a question.
Yeah. When you're talking about basically nominators and validators, you said something about nominators running nodes. I thought like nominators were people that just basically gave their stake to validators to just.
So no, you can. So not nominators are also people who run their node. So see, out of this telemetry, so right now there are these many people connected to the main Polkadot chain. So these guys can be nominators or validators. By default, you are a nominator. So if you can even see where this guy is running from, he's running, for example, this particular node is from Paris. And how do I find out if he's a nominator or a validator? You need to find that out in your Polkadot JS apps. So you can come here. So now say I take an account ID that he's using, right? This is a block hash. So you see, this is the block of what is being generated. So block that is being finalized. For example, this guy, this guy did this block. But how do I find out what is this guy's account ID? That is a good question. Okay, yes, you have this flag here. Can you see this validator, Jibril?
Yes, I can see it, validator, yeah.
Correct. So see, if you see this guy is a validator. This guy is a normal nominator. You see, this guy has an account ID, right? The validator field has some account ID or something mentioned here. For example, this STK center has an account ID which has been mentioned in the validator tab, which means this guy is running his chain as a validator, right? STK center is running this chain as a validator, while these guys who are just normal, like it's not updated, these guys are all nominators.
Okay, I think I get it now.
Yeah. So when you run a chain, you have a role to play. So you will get promoted as a validator. How do you, in an NPOS consensus, your nominators cast a vote for you to become a validator over the period of time you finalizing the blocks. That is how you become a validator. You can't right away start as a validator. You will be a nominator, and as you keep finalizing blocks, are you good at it, you're doing it fast, and you have put enough money, and you're trustable, then there'll be a group of nominators who will elect you as a validator. So basically all that is your NPOS consensus. So NPOS, you can learn it here. So what is see what does node operators mean? You can directly come and refer to this link. I'll just share it here. Yeah. So you even have the algorithm that they have written to figure out all these things. So yeah. Cool. I think, yeah, we can proceed, right? Or anything else you guys want to clear?
Yeah, and coming back to the, can you hear me, Rakesh?
Yeah, I can.
Yeah, I'm getting a message that my internet connection is unstable.
Okay.
Okay. Anyways, so coming back to the question that can we make our transactions fee less, right? So the disadvantage to that is that you're vulnerable to denial of service attacks, right? So if your transactions are completely free, so your chain can be altogether. So it's not a good thing to have like a feeless transaction, right?
Yeah, cool.
So, okay. Okay. So this question is like I think most of y'all should know. Name all the important macros that are required to make a palette.
Palette
Guys,
storage.
I want all of you guys to answer this. So yeah.
Everybody.
Palette.
No.
What did he say?
Runtime.
Name all the important macros that are required to make a palette.
Okay, macros. I think palette call, right?
Yeah.
Call, event errors.
Mm.
Event errors.
Storage was there.
Storage, yeah. 4. There's one more.
Yeah, storage, yeah.
One more very important.
Runtime.
Palette again.
Not runtime.
Config.
Yeah. How can you miss config?
Like you can skip the other macros like event or errors, but you can't miss config. Okay. So the main
apart from this, there are others also. Anything, any bonus points for people who can answer the others. Okay. Anybody remember Genesis config? Palette Genesis config? Genesis, I told you. Yeah.
That's like starting when the block is first started. Yeah.
Yeah. Then you have palette hooks.
Right.
There is something called as hooks, on initialize, on finalize.
Okay, I don't know that one.
Yeah. These are the other macros.
So on initialize hooks are basically hooks are called on every block execution. Okay, so there are
they're called on every block what?
So hooks are called on basically every block execution. So there is a function called on initialize, right? So that is one of the hooks. So you can add your own functionality into on initialize, and you can make that block execution behave as you would like it to behave. So you can read into hooks also. That is maybe a more advanced topic, but once you have a hang of it, I think you can have your own functionalities for every block execution also.
Okay.
All right.
No, I don't understand.
All right. So this is also an important thing. Can you tell me what are the 3 raw origins?
What do you say?
The question is, what are the 3 raw origins?
One is transaction origin.
I think signed
ID. Account
side
ID.
on side of roots, right?
Right, 2 of them are right.
So, Keshav, sorry, I mean, what you said is incorrect, but what Jibril is saying is correct. Just think on those things. Most of 2 things he told. There's one more left.
There are in total 3.
Yeah, I said signed.
Yeah, that's correct.
Yeah, signed on side, and there's I think roots. That's pseudo. I'm not sure.
Root is correct.
Okay.
Signed is correct, and there is one more. All right. So the third one is none. So these are the
none.
3. None.
None or all.
None. So there is no origin here.
Okay.
You can have a transaction without an origin as well. So I'll read out the short documentation. So for root, that is a system level origin. Okay, this is the highest privilege level and can be thought of as the super user of a runtime origin. So root means a super user. Okay, so whenever you are making a transaction, you're making a transaction as a super user. So for a signed transaction, like you said, a transaction origin that we have in our extrinsics, right? So that is of a signed type. So this is signed by some on-chain account's private key and includes the account identifier of the signer. Right? This allows the runtime to authenticate the source of a dispatch and subsequently charge transaction fees to the associated account. So this is the same type that we use in our extrinsics for making the transaction calls. Okay, and the third one, which is called none, this is called a lack of origin. So this needs to be agreed upon by the validators. So since there is no origin to be verified, right, or to be ensured, so the validators come into picture for making this a valid transaction, validated by a module to be included, right? So only when the validators agree upon this transaction, is this transaction included in the block. Okay, this origin type is more complex in nature in that it is designed to bypass certain runtime mechanisms. So it can even bypass the consensus mechanism because you don't have any origin to start with. All right, so one example use case of this origin type would be to allow validators to insert data directly into a block. For example, if you don't want a particular
yeah, I think timestamps, right?
As in timestamps, you can say that. Bang on. Cool. So to summarize, there are three types of origins. One is root, signed, and none. Okay. Okay. So
Lucas was saying one of the time like there can be unsigned transaction. In one of the gaming question, he was saying like a lot of somewhere he was answering like there can be transaction which is sent without signing it. So
yeah, that is how you call an extension. So what this is raw origin type. So origin types can be root, signed, and none. Unsigned is like you're not signing your transaction saying I'm the one who is verifying that I'm verifying that I am the one who's sending the transaction. I'm just sending it from a random signed unsigned origin.
Like an anonymous transaction.
Yeah.
So what about
what will be the source? Like in which category it will fall?
It'll be under signed account ID. It's just that it's not. So when you run the function ensure signed, it will fail. Okay. So for such extensives, you will not need to write ensure signed.
Got it. Thank you.
Yeah, I wanted to ask also what about inherence? I think it's something. I think it's related to this type of.
I'm sorry, inherent. Jibril, I didn't get it.
Yeah, inherent. I think it's inherent transaction or something like that. I think it's related to this raw origins you guys talked about. I think I've seen it somewhere, but I can't really remember very well.
Okay, I'm not sure about it. Probably is it all right to get back? I mean, Dev, are you aware about?
No, I'm not sure. You're talking about inherent. I'm sorry, I didn't get that.
He said inherent.
Inherent
transactions.
Inherent transactions. I think so. I think I saw it somewhere, although I didn't really understand it.
Yeah, there is something called as inherence. Okay. So Jibril, we are not very sure about it. So yeah. But there is something called as inherence. It is there in Polkadot network. It is there in Polkadot network integration guide inherence. Inherence contain information that is not probably true. Let me share my screen. So you have inherent signed transactions, unsigned transactions. So let me just share the link directly for this so that everybody has it.
Okay.
So yeah. So yeah, you have something inherent signed transactions and unsigned transactions. So inherents contain information that is not provably true, but validators agree on based on some measure of reasonability. For example, a timestamp cannot be proved, but validators can agree that it is within some delta of their system clock. Okay, got it. So I think that explains it, right?
Yeah, that explains it.
Yeah. So yeah.
I think these kind of transactions are not projected across the chain, right? That's what it means, I guess. Are not gossip on the network and are put.
No, so inherence is something like your ZK base, your consensus like ZK. Like you can't prove that thing exists, but then you can agree on it. Like people can just hypothetically agree on a situation, right? It may
There-
not be true. Like say I can say dragons exist in this very day and age, right? But like say you and I can agree, like me and Jibril can agree, but can I prove dragons exist? No, right? We're not worried about it. We're only worried that okay, Jibril and I exist. I mean, accept that dragons exist.
I do believe so. Anyways.
True.
All right. Cool.
Yeah.
So can you guys tell me like which cryptographic function does Substrate use?
That's a sub key. No, that is the module. But then SR25519 and ED25519.
Cryptographic function.
No, the cryptographic function. Have you heard of Blake 2?
Oh yeah.
Blake 2 128, Blake 2 256.
Yeah. Okay.
So it's basically called Blake 2 128 or 256 are your levels of encryptions.
Size, basically.
Size, basically.
Variable size.
Is it like similar to how is it something similar to how something like Bitcoin uses elliptic curves?
KCAT.
Is it something like that?
Not exactly elliptical curves, but yeah, like KCAT, you should have heard of the Ethereum uses KCAT.
Yeah,
256 or whatever. Yeah, similar to that.
Okay,
Yes,
it's similar now. Coming to Bitcoin and Ethereum. So, what is the cryptographic algorithm that Bitcoin and Ethereum use?
Yeah, I think it's elliptic curve now. Elliptic curve.
Yes.
ECC. Yeah.
Elliptic curve or digital signature algorithm. ECDSA.
Yeah.
ECDSA. Correct.
Right. And this is the last question. Okay. Can you tell me what is benchmarking used for in Substrate?
I think benchmarking is used to like kind of know how your functions perform, something like that, like how they will run in production. I don't know if I'm getting. I think that's where I understand it. I don't know if it's the accurate definition.
Right. Right. So it has a relation to your extrinsics or your functions, right? So I'll read you the documentation. Benchmarking enables you to measure the time it takes to execute different functions in the runtime and under different conditions. So basically, one use case is that you can identify the weights for your specific extrinsics, right? You can use benchmarking for that. So mostly we use benchmarking for identifying the weights so that you don't have to come up with the weights. That's like the main thing why we use benchmarking. Cool. Anyway, I'll share the screen now. I think I'm all done with the questions. Can you see the screen?
Yeah, we can see.
All right. So like I said, what a SC prefix is used for, or a SP prefix is used for, they are mostly for network responsibilities, correct? And the SP libraries, they are mostly they are used for the outer node or communication between the outer node and the runtime. All right. The frame prefixes, they come between the runtime logic, for encoding and decoding the information. All right. And they basically, they provide the infrastructure for your runtime or your substrate node, right? And your scale codec for serializing and deserializing, storage map, storage nmap, storing 2 keys or storing multiple keys. The final key fee calculated, the final fee has the base fee, the weight fee, the length fee, and the tip. So 4 things are used for calculating the final fee. And these 3 things, the base fee, the weight fee, and the length fee is called the inclusion fee. Okay, the tip is optional. If you want your transaction to have a higher weight or to take precedence, that is, you can provide a tip also. Right, and you know about the important macros that are required for the palette. The 3 origins, root, signed, and none, cryptographic, stuff like that. So basically, why this approach? It's always better to test your knowledge. Just reading the knowledge, just reading something doesn't fortify what you have learned. Always you need to test out what you have learned. Right, so that's why we take quizzes and we take exams, right? So that's why we came to this approach. And mostly this is based off of Substrate docs only. So you can go at Substrate docs. No, all right. Yeah, so this is mostly from the build part. Okay, I'll just paste this in chat. Yeah, so go through this build part, all the sections like introduction to libraries, build process, runtime storage, and all the information required for building a good Substrate node and and a scalable Substrate node. You'll find all the proper documentation within the build part. All right, and and for testing, which is very important. And let's say if you're participating in a hackathon, they'll mostly make you write tests also for checking how well your Substrate node is. So come to the testing part for unit testing, for debugging, and for benchmarking. Everything is there inside this Substrate documentation. So yeah, mostly that's about it for the quiz part. And anything else, guys? Anything else that you want to discuss about Substrate, about blockchain?
I have a question. I just want to clarify what assignments I still need to submit after the Dropbox clone. I'm a little bit lost on that because I wasn't able to see the unique video because I was moving and it's not posted yet. And I just want to make sure that I obviously submit everything that I'm supposed to.
I think it's posted, but I don't think there's any. I think it's posted. The video is posted already, but I don't think there's any assignments.
Yeah, the video is not posted.
So yeah, in terms of assignments, apart from Dropbox, there's no implementing assignments as such. But then, like I said, I want all of you to finish the build tutorials that from Substrate Dev I have sent previously.
Okay.
That and go through the docs, implement the tutorials. These are something that you can do on your own. We are not going to check if you've done it or not. But Dropbox, yeah. Dropbox and Kitties, yeah, Kitties as well. But
yeah, thank you.
I have a question. Where do we go next from here in terms of, advanced reading? Do we continue reading more on substrate.io, or are there any more learning materials so we can, like, what we've learned? Obviously, we still need to brush it up to say we've learned it properly, but like going forward, how do we move forward from here to deepen better our understanding?
Okay, Fahad, I mean, this not just for you, probably let me just answer the question for everybody again. So I'll just share my screen and let's do it again. So what the first step when you want to learn Substrate is that you come to substrate.dev. The network is a bit slow, but yeah. So you come to the developer section and you come to the docs. And so first thing, you understand the fundamentals. This part we've already covered, so no need to figure out the entire thing. Then you get into the hands-on, so how you write a palette and stuff. And now when you come to Rust for Substrate, we haven't covered everything here, right? So obviously it's not possible for us to cover what we have sessions for only about 2 hours and about 6 sessions, right? It's not logically possible to cover the whole thing, which is why I want all of you guys to finish this part, like the build part, because this compromises of the thing that one requires to build on Substrate. That is all one needs to know. If you want to start building anything on Substrate, like how Kitties, you built a palette, you need to know how to build a palette. And the second thing is about tight coupling and loose coupling. Then the third thing would be about paying fees on a transaction. And the fourth thing is probably how you talk to another palette or talk to another chain of sorts, right? So I think these 4 things are mostly enough for anybody to finish, to basically gain knowledge on writing palettes. So that part is done. So once you're done with all that, the advanced things are like test cases that you write. And after that, you can also start finishing with these tutorials where get started, building a chain. These are all basic. It's fine. Working with palettes, we've already covered all of these things. There is nothing to here. Smart contracts is Ink smart contracts. Again, Ink smart contracts, we had a session, but if you want to use Ink smart contracts, it's up to you. Like, it's your personal choice. So yeah, you can do that, but we were mostly focused on building palettes. And this connect to other chains, it's not very necessary at the moment. It depends on what kind of things that you want to do. So the basic thing that you want to ideally start building is start with small projects that you can build on your own, that you can put on your resume or something that you've done, like say like an NFT marketplace. So some of the major projects that we will do are NFT marketplaces, gaming. So that is where I said, please come here again, go to the marketplace, go to projects. You have multiple projects, you get project ideas also looking at them. You don't need to build advanced projects like what they have done. We'll build something very simple that just for our learning, right? So like if there's NFTs, you want to build a small NFT palette, there's something called as palette uniques that you can explore to build NFTs. And then you can build something on the gaming front. You can build a small, the most simple thing as a developer that when I started off is always building a tic-tac-toe, building a snake game, building a chess game. So I have built all these things whenever I start my say normal programming thing. So if you are into these things, I mean, like learning just to write a lot of code, get hands-on with the code, then implement a tic-tac-toe game on Substrate, right? Agreed, it's not a proper production environment application that makes sense. No, it is not. We are not doing that for that. We are implementing that so that we can get more hands-on to the code. Right. So this is the three-step process for anybody to pick up on Substrate. I would say, just to compromise it in simple, you just come, learn, start developing palettes, which we've already started. Second, understand all the palette structures that are possible. That way you're confident of, okay, now when I want to use another palette, when I want to have custom functions, you want hooks, you want Genesis configs and all that, and then start building small projects. And once you're done with all that, the major thing that anybody has to do is look at code, look at other people's code. Like I showed you, there are all these guys have all these code bases are open source. BitCountry is open source. Everything is open source. You can see the number of stars also. So everything on Web3 is open source. Open their code, look at what they are, how they've written their palettes and everything. So there can be one question here, like, why do I need to do all this? Or are you losing motivation while doing all this? So one thing that I myself, to stay motivated is, for me, Rust is the main thing, like for me and Tejas. So if it is Rust, we are like motivated enough to do anything. But then if you still want more motivation, you start getting into hackathons. There are so many hackathons that are coming up. Like I said in my last session. So I don't know when the new hackathon is for Polkadot, but I don't have the date. But I know it will be happening sometime in November. So if you guys are good enough, I myself will be competing there. So you guys can compete along with me. Like, I mean, not as a team, I have my team, but yeah, people are, it's open if people want to join, but you guys can bring in your own teams and start getting ready for such hackathons. We have a team have already attended hackathons. So you already have so many hackathons that are happening, right? So you can come here, look for Polkadot. There must be, so see, one thing, you have Moonbeam. Moonbeam is something that is written on Polkadot for connection to EVM, Ethereum. So right now it's going on till September 26th. If you guys can join, build on it, it's well and good. Second, you have Hack Kusama, but it's got over. So Hack Kusama has got over, but yeah. But similarly, you have multiple hackathons. So if you see, even Polkadot Hackathon North America edition just got over on July 13th, and you must actually see all the winners. There's a YouTube video for all the winners that you can actually see, that I would recommend everybody to watch. This is a say a dose of motivation for people in case you guys want to. This one, so you see, all these people are normal people and who have started. See, this guy has won XM.AutoStake. Substrate Social has built something called an exchange where they've won. Then these are all the winners basically, and each winner, the first winner got $30,000. That's a lot of money, right? That's a lot of motivation. So yeah. So yeah, these are mostly the ways for, it's not just Substrate development, but for anything, this is how you need to do it. So first off, build projects. Second off, read code. Third off, write a lot of code and understand like the depth of the language and the domain that you're working on. Fourth, implement that maybe as a production level application in an organization for you to get a job, or you get a job on that thing, or work on hackathons, which will eventually leading you to get job opportunities. I hope I've answered that, but yeah.
Yeah, amazing. Thank you for that.
Sure. I'll just leave the link to the winners here. So yeah.
Do you think at this level of qualification, I mean, the practice of make us eligible for the job there?
So
at
in
this
terms
level,
of
the level we have right now.
So obviously, like what we have gone through in the Polkadot, I mean, like the bootcamp is mostly the basics, right? We have taught you how to write palettes. Now that is the basic knowledge enough. But then as you keep going into the domain of blockchain, what is blockchain used for, the use cases, what apps are being built, and those are all like something that you'll have to self-explore, self-build, and in terms of what a company looks at while you're hiring is, are you able to write a palette? Do you know what Substrate is? Are you aware of all the palettes that are there in the ecosystem? Are you familiar with writing a lot of code? Are you familiar with the errors? Can you fix the errors? The main skill for a developer is always you need to be a good debugger. Anybody can write code. Anybody can write code, but you need to be a good debugger, and that's what gives you the distinction between developers, good developers. So yeah.
Cool, thank you.
So how many of you all are new to blockchain?
New as per development or just knowledge wise?
Like new, I mean, I didn't know blockchain, now I'm that. Or have you all been like into this? Have you all been into this domain for like 1 or 2 years?
Okay, for me, basically, I think I started learning about blockchain basically, I think around 2020 July or August. Yeah, so that's about 2 years now.
All right. And
development, I think development was like probably 9-8 months, and I started with like Rust as my first language and everything. Yes, yeah.
All right. You started with Ethereum, you said, right, Jibril?
No. I started with like when I got into crypto, first like okay, trading, holding, and everything. Then I was like curious. Okay, what makes this thing very valuable? Then I started learning about the technology and everything. Then I think I kind of got sold on the would I say the value proposition of Polkadot, like with the interoperability and and connecting to other chains. So I was like, okay, I'm interested in this. So I started like learning how to like. That's when I started learning how to code with Rust. Like Rust was my first language, basically. I think last year, November or December. Yeah. So.
All right.
For me,
Okay.
For me, it's since June.
Oh wow.
New baby. Sorry.
Super.
That's fine. So one tip for anything like looking for a mainstream job is just get a good project on your portfolio. A Dropbox is a good project, but then the version of Dropbox that is being asked is probably too basic. You'll need to maybe build on top of it, build functions on top of it. The main thing is you have to bring uniqueness to your project. Whenever we are recruiting, we are looking at how unique you are and how good you are at problem solving. So like I said, one needs to be a good debugger and one needs to be a good problem solver in terms of, when it comes to development or be a software developer. So yeah.
I think two things are more important in this. It's like the first thing would be how well you know the framework. Substrate. And second thing would be catching up on new Rust functionalities, and going into deep diving into algorithms, doing that in Rust, and maybe applying those algorithms in Substrate. Also creating a palette. If you're good at maths, you can create new algorithms for a specific palette, and then you can open source it. All of these things will help, and will really make you really make you a good Substrate developer and a blockchain developer as well. So
Yeah.
Some common projects that are right now trending as, like I said, NFTs, gaming, metaverses. Then you have DeFi projects where you have liquidity pools, money lending, crypto lending. Then you have automated market makers. You write your own AMMs. These projects have a lot of scope. Then in terms of DAOs, what is a DAO? Does anybody know what is a DAO? Decentralized Autonomous Organization.
Yeah, DAO is a group of people who decide about the future action. So they have to agree on something in a decentralized way. So there is a very important component of DAO is the voting. So through voting, they agree on something and proceed.
True. That is one what you said is one such feature, but DAO is a main organization where builds the custom like functionalities to solve use cases. You provide functionality to solve problems that other come to you for. So yeah, you build custom DAOs that solves a unique problem, and that's why you can find a lot of DAOs. Like even in the hackathons, you have categories. You have categories for DAO, you have for DeFi, you have for gaming, you have NFTs. Then what else? You also have some DEXs, exchanges. So where DEXs are basically your regular exchanges where you go buy crypto like Bitcoin or Ethereum, but now you want to do it on the decentralized exchanges. So yeah, these are the most trending projects that are there in line. And if a company is hiring you, they're hiring you for something under these domains. So it is maybe a common sense to upskill ourselves in such domains.
Yeah.
Cool. So I think we can close the session if anyone else has anything. Otherwise, we could close it. Okay. So thank you, Lokesh. Thank you, Tejas. This was a super interesting session, and especially the quiz part. I had a lot of fun. It was definitely a fun way to put the knowledge gained onto the test. So before we close, we would love to hear what you guys thought about the entire series. You can leave your feedback in the chat box, and hope you guys are taking some significant learnings after investing almost 3 months of your time. And so you guys can definitely keep in touch with your mentors on Discord, ask all your questions there, and we shall see you next Saturday in the guest session. As mentioned before, we have Faisal Ahmed from Polkadot, and he'll be conducting a live workshop on introduction to testing of substrate palettes.